I've spent the past 10 years of my life using AI to improve energy systems. That's why I co-founded Wattlearn. Wattlearn is a software as a service, AI software as a service company for optimal operation of battery projects across the electricity grid. Probably most of you, it's not going to take too much convincing to agree that batteries are going to be an important part of our electricity grid globally in the near future. But it is not going to be as easy to convince any of you to install a battery for your next project. That is mainly because it is still quite difficult to build economical battery projects, no matter where across the electricity grid we are talking about. That is due to the necessary balance between three competing objectives: the overall cost of these projects, the value that we generate from these projects, and their effective lifetime. These are competing objectives, and the industry mainly has been focused on reducing the cost of hardware. But that is only 1/3 of the whole problem. Balancing between these competing objectives and three pillars of battery economics is a largely complex and multidisciplinary software challenge. That is where Wattlearn comes in. At Wattlearn, we are turning batteries into smart participants of the electricity grid. To make them smart, we first give them foresight about all the factors that they need to know ahead of time to make optimal decisions. Then we give them optimization and decision-making abilities. Let me show you a real example, which is not going to work. OK, this is supposed to be a video. Just imagine that on the top, you're going to see the revenue of a battery sitting in Southern California and creating like revenue using existing software solutions. Then on the, above that, you're going to see a line, Wattlearn's, what these batteries would have made using Wattlearn's AI technology. The difference is something around 150 to 200% more revenue. That is enormous opportunity to capture. But in order to capture that much opportunity, we did not have to cycle the battery more and degrade it faster. As you would have seen on the bottom, you would have seen how the cycling are going in the traditional and default approach versus our cycling. And you will see that, in fact, we are cycling the battery 65% less. So that means that we only cycle the battery when it makes sense. We do not cycle the battery just because. We cycle the battery when the expected revenue is greater than the degradation cost. This is what a smart battery looks like. OK, if you are interested to hear more about batteries that think for themselves and you actually want to see the video live, let's talk after this.
Great.
Thank you.